In this section, we are going to have a look at Razor Pages, the new framework called Blazor, and WebAssembly. We will begin with an overview of what WebAssembly is and how it fits in the Blazor ecosystem. And then we will just create a new project with Blazor and work on it. Before we can begin working with Blazor, let's first get some definitions out of the way. What is WebAssembly and what is so important about it? WebAssembly is an open standard. This means that it is a list of publicly available specs and rules that essentially define a new language for the web. JavaScript is no longer alone. WebAssembly can be viewed as a compilation target for other languages like C++, C#, Java, and even JavaScript itself. With WebAssembly, we can view the browser as a high-level, high-performance virtual machine. This means that the browser is to WebAssembly what the CLR is to C#. WebAssembly also provides us with multi-threading that has been missing from JavaScript for good or bad reasons. Some of the use cases of WebAssembly include augmented reality applications, virtual reality applications, games, single instruction, multiple data applications in which a single operation is performed in large datasets in parallel, or you can just simply use WebAssembly to make traditional apps faster. Now let's see what Blazor is. Blazor is an alternative to JavaScript frameworks like Angular, React, and Vue, only it is written in C#. It offers two hosting models. First, there is Blazor Server. With Blazor Server, you write your application's business logic in C# and your front-end client application communicates with it via WebSockets with SignalR. So essentially, the main bulk of the process is running on a server, not the client. This means that the JavaScript main thread can delegate tasks to your C# server, thus offloading the browser from heavy operations. Then we have WebAssembly. Instead of having that two-way communication between the client and the server, the C# code gets compiled down to WebAssembly. We are going to be working with Blazor WebAssembly for the rest of the section, and in order to retrieve the application template for Visual Studio for the Blazor WebAssembly template, you have to run this on a PowerShell. Once you're done, you should be seeing this Blazor WASM short name in the list of templates for the .NET CLI on a PowerShell or CMD console. Now that we have the template installed, let's go ahead and open up a new instance of Visual Studio 2019, and I'm gonna have to click on the Blazor app template, give the project a name. I'm gonna go with the typical to-dos application that we use for these recipes so far, and we will use in this section and the next. Now, at the time of recording this video, the WebAssembly template is still not yet supported by ASP.NET Core 3.1. If you're watching this and the WebAssembly choice is available for ASP.NET Core 3.1, go for it. Otherwise, we just have to downgrade the version just for testing this out. Once this is done, we can start inspecting the project. If you have a look at it, it just looks like an ASP.NET Core MVC project. It has very little differences. It even says ASP.NET Core in this welcoming screen. So let's start diving into the files and what they do. You see that we have a program and a startup.cs class. We're gonna ignore the program class, it just bootstraps the application. If we head over to the startup class, you see that this is how you add the application component. You have a configure services function, which obviously configures services for dependency injection. So if you want to have an HTTP service, you could register it there. If you want to map DTOs like we did in the previous section, you can do it in this file. So for all intents and purposes, this is the same startup class that you would see on an ASP.NET Core Web API or MVC application. Now, if we have a look at those shared files, they are Razor pages, and we are going to dive into Razor pages in the next videos. But for now, you can think of a Razor page as a page where C# is combined with HTML on the same file without having a need for a controller. Then you have the root folder for the client application, and this is the index.html. You can see that we have the framework itself is packaged as a JavaScript file that is inserted right before the end of the body tag and takes care of the rest. Let's run the application and see how it looks like. Notice the loading indicator is what we found in the index.html, so it's the first thing that appears on screen right before we get to this screen that is now running fully on Blazor and WebAssembly. So you have a sidebar on the left. Obviously you can change that. It's not something that we should keep if we don't want to keep it. Let's head over to that counter page and see a live example of code written in C#. So when I click on this button, the counter increases, but this doesn't happen in JavaScript. It happens in C#. And these here, the weather forecast data, this was all fetched using C# on a Razor page. So you understand that Razor pages are important for Blazor. Most pages here are constructed as Razor pages. And this is an example of the navigation menu. It's a Razor page, but it's mostly HTML. It doesn't have that much of code logic. I'm going to copy this nav link and change this to to-dos and change the href to to-dos. And now I'm gonna have to create a new Razor page. So I'm gonna click on add, and you can either go to Razor page or you can click on new item and select this Razor component, and this creates a new to-dos.razor. And this is enough for even registering the path /razor. We don't have to go in a router and register it. We don't have to use an attribute like we do with controllers. We can just run the application and head over to the /to-dos subroute, and this new page will be here. Razor pages are great, but sometimes you just want to take advantage of the large ecosystem of libraries and functions that exist with JavaScript.